Hello all, welcome to the video. Today we are going to solve the Leetcode problem longest substring without repeating characters. The problem statement is this. Given a string, find the length of the longest substring without repeating characters. For example, the input string ABC, ABC, BB, the output of the longest substring without repeating character is 3. That is, the longest substring is ABC. So we are going to solve this using three approaches. One is brute force, the second one is using the sliding window approach of a set, and the third one is using the dictionary approach. Let us start with, so using the brute force method, I will solve this problem by generating all possible substrings, and I will check whether each substring contains unique characters. I mean to say, I will start from index I and extend substring to every index j, check if characters are unique and update my maximum length. Look, the function definition takes one input and returns an integer. Find the length of the string. I am initializing the maximum length to keep track of the longest substring found so far. And then the outer loop is for choosing the starting index. I try every possible string positions. For example, A, B, C, A, B, C, B, B, I equal to 0, I start at A. I equal to 1, I start at B, and so on. The next, if you could see, I am creating an empty set which is going to store characters already encountered in the current substring. Look for the inner loop. The inner loop expands a substring. It starts from index I and moves right one character at a time, builds the substring. Next, I check for the duplicate characters, after which I stop the current substring and add the character to the set and update the maximum length. I am returning the maximum length. So this algorithm runs, the outer loop runs n times and inner loop runs n times, so it is order of n squared. And the very important variable here is seen. It can set the maximum number of characters. So set can contain at most all unique characters at a time. So the space complexity is also order of n. To be very specific, it is order of minimum of n comma the actual character set size. So let us do a dry run of this. For the input string ABC, ABC, BB, using the brute force method, I start at index 0. So index 0, A. A is valid, yes, length is equal to 1. Next, AB, valid, length is equal to 2. ABC, yes, still valid because there is no repetition, length is equal to 3. A, B, C, A is again repeated, so it stops. So the length of the substring without repetition is 3. Again I start as index 1. Index 1, it is B, BC, BCA. After BCA, it is BCAB where B is repeated. So it stops and this repeats, the iteration repeats. Fine. So final answer I get is 3 because the longest substring without repetition for this input is 3. So as we have already discussed, the time complexity is order of n squared and space complexity is order of minimum of n comma the character set size. Right? So we have solved this using the brute force method. Right. So the next approach is called the sliding window using the set method. So here we are going to maintain a window s of left, right plus 1 that always contains the unique characters. So I am going to maintain a window that is going to contain unique characters. If a duplicate is found, I am going to remove the character from the left until the duplicate disappears. So for example, the same string ABC, ABC, BB, the window will grow. First it will be A, then the window will be having AB, then the window will be having ABC. Again the window will be having ABCA. A is a duplicate, so the duplicate will be removed from the left of the window. So this is what is happening in the sliding window using the set approach. So the left is the start of the current window, right is the end of the current window, Seen is set of characters currently inside the window. Maximum length is the longest valid window size seen so far. So think of the window like a rubber band. Right expands it to the right. If a duplicate appears, left shrinks it from the left until the duplicate is removed. Okay. So you can see the function definition, which is going to take the string and return the length of the longest substring without repetition. I am creating an empty set. We have already discussed what is seen, left, right. Okay. I am creating an empty set, initializing the left pointer and the maximum length. I am moving the right pointer. So moves right from the first character to the last character. And remove duplicate. You can see the while loop, while s of right in scene. So if current character is already in the window, we have a duplicate. So you shrink the window from the left until the duplicate is gone. Remove leftmost character, move left pointer forward and add current character. You update the maximum length. Right? So the current window length is right minus left plus 1 and you return the result. So each character is added to the set once. Very important point to note. Right? Each character is added to the set once, removed from the set once. So the total operation here becomes order of n. And the space complexity is the same. Order of minimum of n comma the character set size. Right? So for the same input, what happens? Initially my right will be 0. The first character is a. Yes, I am going to add it to the window. The window has a. The length of the window is 1. Maximum length is also 1. Right becomes 1. Next character is b. I am going to add. The window will have ab. Length is 2. Max is also 2. Right becomes 2. Yes, c. You are going to add c. abc. Length is 3. Max is 3. Right becomes 3. Character is a. A is a duplicate. Remove left until no duplicate. So the window becomes BCA. Length is 3. The max is also 3 here. Right becomes 4. Character is B. Again adjust. The window becomes CAB. Done. So it repeats until right is 7. Look, the character is B. Again I adjust. Window has only B. Length is 1. The max length is 3. So far the max length encountered is 3. So which is the first largest substring? It is ABC. BCA is also the correct answer. CAB is also the correct answer. Right? So this has a time complexity of order of n when compared to approach 1. Why? Because each character is added to the set only once, removed from the set once. So the key idea takeaway is that expand the window using right. If duplicate appears, shrink the window using left until all your characters are unique and track the largest window size. So this is the second approach. Moving on to the third approach, it is sliding window approach with dictionary, which is the most optimized approach. Instead of removing characters one by one, as we have seen in approach 2, here I am going to store the last seen index of each character. When a duplicate is found, I am moving the left directly to the last seen character plus 1. This is what is the optimized approach doing. Right? So set based sliding window in approach 2 may move left many times, whereas approach 3 sliding window with dictionary jumps directly to the current position. Though the time complexity is order of n, this is an optimization here. So dictionary approach jumps directly to the correct position. Instead of storing only the characters in the current window, we store the character along with the last index where it appeared. Example, when a duplicate character is found, we immediately move left to one position after its previous occurrence. So this totally avoids removing character one by one and it makes the algorithm very efficient. Look at the algorithm. I am defining the function, creating the dictionary which is storing the last index where each character appeared. I am initializing the left pointer, initializing max length. I am looping through the string. I'm checking for duplicates inside the current window. Look at the if ch in last scene and last scene of ch is greater than or equal to left. This is most important. This condition means the character has appeared before its previous occurrence is inside the current window. If both are true, it means that we have found the duplicate. Okay, so you jump the left pointer and move the left pointer to one position after the previous occurrence, right? So why this is better? Because the set based sliding window will move the left pointer many times, whereas the dictionary based sliding window jumps directly to the current position, right? So after which you update the last scene and the maximum length and return the result. So here each character is processed only once, so it is order of n, and the space complexity is the same, right? So look for the same input. This is how my right and the last scene looks. So initially right is 0, character is a, yes. So last scene stores the position index. Yes, the window becomes a, length becomes 1, max becomes 1. Right is 1, yes, character b is added. So a is at position 0, b is at position 1. So this likewise the iteration continues until the longest substring without repetition is returned. So the complexity is again order of n, and the space complexity is order of minimum n comma character set size. So comparing the brute force sliding window set approach, sliding window dictionary approach, the brute force has the time complexity of order of n squared, whereas all three has the same space complexity. This brute force, you need to understand the initial solving purpose. You need to follow this brute force for basic understanding. Standard interview question, you can use sliding window set approach, which is an efficient approach to solve. The most optimized and a unique impressive approach is the sliding window using the dictionary approach. You have any other optimized solution? Do comment. Thank you. Happy learning.